Section 7.4, the area of a triangle. And for the first minute, when students look at the title, say, wait, the area of the triangle in trig, I mean, we only know that was in geometry, and we learned about the area of the triangle back in geometry, and we define it as the area is 1/2 base times height. That's how we know it back from elementary school. The area of a triangle is 1/2 base times height, which came actually from the area of the parallelogram. So each parallelogram can be split into two equal triangles, and the area of the parallelogram is base times height. So that's why the area of the triangle formula 1/2 base times height came from. But here we are going to see introduce three new formulas for the area of the triangle. Okay, the area of the triangle, using trig to prove those formulas or theorems. And these formulas that we have, they come in three different cases. The first case is side angle side. So we have two sides are given and the included angle is also given. What would be the area of the triangle in this case using trigonometry? Well, always we're going to look at the triangle as if it's ABC, and as we know from before, this is small c, small a facing A, small b facing B. What would be the area of the triangle in this case? It's 1/2. The base here is AB, let's say, and the height is the perpendicular line, call it H, so it's CH, C capital H. And in this case, the area is 1/2. AB is small c, and CH is small h. But that h might not be given. Remember, what is being given is a side of the triangle, two sides and one angle, not the height. So I want to somehow find the height in terms of the other sides or angles, the given sides or angles. So how do we do this? You can pick either triangle, maybe this triangle or the right triangle, the triangle on the right side. So from here, I'm going to find sine A on the side by SOHCAHTOA is the opposite over the hypotenuse. So H over B. If you cross multiply, H would be B sine A. B times sine angle A. So that's what's going to go here. So the area is 1/2 C. H is B sine A. B sine A. So then I can just simply rewrite this. The area is 1/2. Let me just rearrange the letters. BC sine A. So that gives me the formula for the area of the triangle. Given angle A is given here, and B and C. Notice, if A is given, this is angle A, and B and C. So C and B are given. Do you see how side angle side? So then I can go straight forward into this 1/2 BC sine A. Notice I use angle A. Can someone use angle B? So here we have angle A. Can someone use angle B or C? Yes, you can. And the easy way to memorize this, we can do 1/2. Notice how we have BC. What about if it was AC? If it's AC, then it's sine the third letter angle, so it's B. Or what about if someone started with AB? AB, then that would be sine C. So all these formulas can be proven the same way. So that's one way to find the area of the triangle using trig. So this is only one of the formulas, not all the formulas, just one of them. There will be two more that we're going to go over today in this section. The next thing always to do is really look at an example. So let's say find the area of triangle ABC if angle A is 29.6 degrees, side B is 4.28 centimeters, and side C is 5.33 centimeters. Okay, so you can draw the figure and label the stuff on it, or you can go straight looking at, okay, so angle A is given, so this is angle A. They give me C and B. So they give me, this is side angle side case. So I can go ahead and use the formula that the area is 1/2. The two letters that are given are the two sides B and C. So BC sine angle A. and all I have to do is substitute. B was 4.28. It's important to substitute the numbers in. Sine angle A, which is 29.6 degrees. And then all we have to do is just put that into the calculator and get the area to be about 5.63. Don't forget the unit measure, which is centimeter square. So that formula works in any triangle with cases that side given, where angle is the included angle between the two sides. So the next case, how about for angle side case? Angle side case. Well, if I'm gonna just draw the triangle again, that's the first thing I do. I just draw the triangle so I can see everything, and then I want to see what can I do with this figure. So the area is 1/2, the one we know, AB sine C, let's say. Right? That's what we learned earlier. That's one of them. But let's say for the angle side, let's say they give me angle A, angle B, and the side A. So let's say they give me, I'm gonna highlight them. Those are given ones. Those are the given ones. So I have only A. I don't have B. And I don't have angle C. But can I find that out without like trying to go through a different formula? Well, what do you think? What can be done here? They give me the two angles A and B. I can find angle C by doing 180 minus the sum of the other two angles. So I can find the measure of angle C by doing 180 minus the measure of A and the measure of B. So that will give me C. Then I'll be able to find sine C. Well, A is given. I still need to find B. How do I find B in this case? I use law of sines. Law of sines will take care of that. But we do not want to go through all these steps. Do the subtraction and then come back and use law of sines and put it. So it's going to take more time than what we expect. But we can prove another formula here, another thing to do. What is given, I'm going to use law of sines. So by law of sines, on the right side here, they give me A and angle A. So sine angle A over A. They give me angle B, so I'm going to start with sine angle B over B. From here, cross multiply B sine A equals A sine B. I can find what B is. So B is A sine angle B over sine angle A. So why did I find that? Well, because I'm going to go on and substitute that into the formula here that I just wrote down. 1/2 A. Instead of B, I'm going to put the A sine B that I just got over sine A. And keep sine C the same. So I can rewrite this in kind of like more clean way. So A times A is A squared, sine B, sine angle C over 2 sine angle A. This is a formula to find the area of the triangle. Here, if you know this formula, you only need to do one step, and that step is really find the third angle, because they give you two, you find the third one. So here they give me A and B, I just find C by doing 180 minus the sum of the other two angles. And then small a was given, so I just substitute into the formula. Now based on this, can I come up with a formula for if it's not like, what about if not A and B are given, maybe angle A and C are given and C is given, or maybe B and C and A is given or B given, like how do I work that out? So to get the other two formulas, so the same works for the other formulas, which is similar to this. If happen they give you B, small b, so that's going to be B squared here. There's always a 2 here. This A matches angle A. So if there's a B there, so that's going to be B here, sine B. And whatever you have in the denominator, then doesn't go in the numerator. So that will leave only sine A and sine C. That's how I memorize it. That's another one. What about if C is given? Well, small c given, always 2 here, and sine C must match. Since there's c in the denominator, we do sine A, sine B. Okay, so this is another formula to find the area of the triangle using trigonometry. And again, after each formula, it's good to look at an example. So let's say we would like to find the area. Would like to find the area of triangle ABC, given A is 37 degrees, B is 51 degrees, and small a is 6.43 feet. So how do we find that out? Well, let's see what's given. A is given, so the first thing I'm gonna do, wait, how am I gonna know if I'm gonna use 1/2 AB sine C or this one that we just proved? Well, always triangle is it helps us to find what is given, what is missing. This is A, 6.43, angle A is 51 degrees, 37 degrees, and B 51 degrees. So that's angle, side, case. It's not side, angle, side. So the AAS case, we go with the formula we just spoke about, the latest one. There's always 2 here. A is given, so A squared, so that goes sine A down there, and then sine B up here and sine C. Okay, now all we have to do is substitution. A is 6.43 square times sine angle B, which is 51 degrees, sine angle C that I don't know, but I do know sine A is given 37. So to find C, as I said before, is always on the side, 180 minus angle A plus angle B. So angle C is 180 minus, A was 37 and B is 51. So then angle C equals 92 degrees. So we don't need this. I can substitute that in there. So put that in the calculator now. You need to be careful how you put that in. Make sure the mode is degrees on the calculator and key it in as I did earlier myself, and I got 26.7 up to 1 decimal place, 3 digits, so that's feet square. Don't forget the unit. That's the area. What would be the next case? That is the case for SSS. If they give me 3 sides, what do I do? Well, we have a mathematician, his name Heron. So he proved a formula to find the area of the triangle if you know the 3 sides. And I'm not going to really prove it here. It's going to take a lot of time. There's so many steps. But he used trig. That's why we are introducing it in this section. If we have a triangle ABC, small a, small c, small b. So what Heron proved, he said, we find small s by adding all the sides up divided by 2. That's basically, we call it semi-parameter because that's half of the parameter of the triangle. And what he proved that the area of the triangle, after you find that s, is always given by s times s minus a times s minus b times s minus c. So that's what Heron proved. It's a very interesting formula because it doesn't have like fractions or complicated stuff. It's a straightforward formula. They give you A, B, C, find S, and substitute into the formula. And as I said, the proof is a little bit longer than the other ones that we did earlier. How do we apply this to an actual example? So let's say find the area of triangle ABC if A is 15 meters, let's say, B is 13 meters, and C is 22 meters. Okay, now you can tell they only give me sides, no angles, so that's SSS case. So it's SSS case. We use Heron's formula. So first thing we always do, find the small s, which is a plus b plus c divided by 2. A is 15, b 13, c 22 divided by 2. And then what we get for this is 50 divided by 2, 25. We get s to be 25. Then the area, I usually write it down so I don't forget it. S times s minus a, s minus b, s minus c. Okay, s is given as 25. This is 25 minus a was 15. 25 minus b was given 13. And 25 minus 22 for c. Now, you can put all that in the calculator and get an answer, but I'm going to show you how I do this with no calculator first and simplify it to the best we can. That's 25. 25 minus 15, that's a 10. And then the next one is 12. And the next one is 3. So how are we going to simplify this? First thing, this 25, I keep an eye on it because I'm going to take this out in a minute. The 10, you can prime factorize it 2 times 5. 12, 3 times 4, because 4 is a perfect square number, so keep it like so. And the last 3 stays as is. Now the 25 comes outside as a 5. The 4 comes outside as a 2. These 2 3s, they come outside as 1 3. And that will leave 2 times 5, 10. So that gives us 30 square root of 10. So an answer like this on a test, that would be perfect. But if you like to know what is this on the calculator, that's 94.9 meters squared, rounded to 1 decimal place. So either one would be fine. Now, a question that someone may ask, if they give me the SSS case and I forgot about Heron's formula, or I really didn't know that I need to use Heron's formula when I'm taking the exam, can I use the other ones that you taught us today? The answer is yes, we can. So the question, can other theorems or formulas be used for side case? The answer is yes. So for example, like we are given 3 sides. So this is A, B, C, this is small a, small c, small b. You're given 3 sides. So this is given, given, given. You pick any of the angles you like. Let's say I want to find angle C. So we first use law of cosines to find the measure of angle C. Angle C. As soon as you find angle C, watch what you have now. Now you have this, and the angle included between them. Then use the formula that we started with today. Formula for angle side case, which is 1/2 AB sine angle C. And that will give us the area. So all these 3 theorems or formulas, they are connected to each other in a way or another. All of them are connected using trigonometry to really be able to prove them and or use them to find areas of triangles. Now there's more extension to this Heron's formula, something called Brahmagupta's formula that works for quadrilaterals. But in this section we're only focusing with triangles. So the good thing about it is just it shows us how we use trigonometry to really find areas of triangles. So it's not only a matter of 1/2 base times height. But notice all these things that we proved in this section, like starting with the first one, the case side, angle side, we really start using 1/2 base times height, and we build on it. So we took that from there, and then we got the 1/2 AB sine C, and then we took the 1/2 AB sine C, and then we proved the next one. And then from there, like if you look at Heron's formula, the proof of it, it also uses the other formulas that we proved earlier, and the combination of law of sines and other trig identities. So that's what this section is about, finding the area of a triangle using trigonometric, either trigonometric formulas, or we use trigonometric formulas to prove Heron's formula, which can be used to find the area of the triangle.